So now we move on to part 2 of the DC motor and how it works. And I want to come down here to look at this sequence of pictures, again taken from England. And we start with this one here. This is an end view. So this is looking from the end. It's not a 3D picture. And just so that we can all be clear, the commutator is in here. So I'm just exaggerating it a bit. The black dot in the middle is the axle. And on the left-hand side, the current's coming towards us, which is at side A. And on the right-hand side, the current is going away from us from side B. And if you if you use the left-hand motor rule, you will confirm again that the forces are like this. And now we can see it's going to spin. But I finished last talk by saying, well, what exactly is the commutator for? Well, we know it's to allow contact to be made with the rotating coil, but it also performs another very important function, which we can tell by looking at the sequence of pictures below. Again, I'm just going to make the commutator a bit more obvious. It should be round. And you can see that what's going to happen is that the coil is going to spin, but when it reaches a vertical point, if we still had a current, then this force would be this way, and the force on side B would be this way, and instead of actually making the coil rotate, it would just be pulling it apart. So that's pointless, and so we'll get rid of that. And so just to remind you, the magnetic field is going across this way and across this way from north to south pole. So we can show that the force on the current A would be upwards and the force on current B would be downwards, but as I just said, that's pointless. We can also see that in the commutator, momentarily, the contacts, the brushes, are not touching. So actually the current would switch off, which is probably pretty sensible. But as it turns, it continues rotating with its momentum. We get to part C. And what we see is that the top half of the commutator, the top half of the split ring, now touches the other side of the battery. So we get this top half now touching the right-hand side, whereas before it was touching the left-hand side. And the right-hand side is positive. And the dot that we had at side A is turned into a cross. Now, you will remember that the dot means the current's coming towards you, but the current means that the cross means the current is coming towards you. So this force that was up on A will now be down on A. Similarly on B, the force on B will be upwards. The magnetic field, by the way, has not changed. It's still going from left to right, like that, through the coil. So that means that our rotor is going to be okay for another 180 degrees. And what do you think happens then? After another 180 degrees, going from picture C to D to E, then we'll get back to picture B and then C, and then the current will switch back. So the commutator, with its split rings, switches the current. So let's just make our picture a little bit smaller and write that in notes. The commutator, it has got two M's, I checked that out. The commutator has two functions. The first function is that it connects the rotating coil to the non-rotating battery, or it could be the mains, of course, via the carbon brushes. And they are sliding. So that's the first very important aspect of the commutator. But what we've been looking at today is that the commutator also reverses the current every 180 degrees. Allowing continuous rotation. Now you might say to yourself, why doesn't it stop in position C? Well, one of the answers is because it's already moving. So because there is no force, there is no turning force at position C. So when we get to position C, it could stop. And actually, our simple kit sometimes does stop in that position. Another problem with our simple kit is you have to give it a flick to get it going. That wouldn't be much use for your electric drill or for your Hoover or for any other electrical appliance if you have to give it a flick to get it going. So next time, we'll have a look at how we improve this design and make a really good DC